Chapter 18, Renewable Energy Resources. So basically everything we've talked about this semester leads us to now ultimately what are the solutions to the problems. What can we do to get away from the non-renewable sources of energy, to get away from the types of polluting technologies we use? So this chapter is going to cover some of those issues. And again, I think I started out the class saying this, so it's probably appropriate I end the class saying this. But the solutions have to ultimately start with each and every one of us in our homes. Us as individuals have to be what makes the difference. So one of the main sources of energy consumption, as we talked about, was commercial and private buildings. And so most buildings, the energy we use, the electricity we use, generates heat loss through things like light bulbs. And again, this image just kind of shows some of the heat signatures for different types of light bulbs, the incandescent to the compact fluorescent on the bottom right to the LED type of light bulb. And basically, again, whether we're homeowners or we rent or even live in an apartment, each of us can probably identify some things around our own home that we can do. For example, replacing light bulbs as they burn out with, again, either the LED type technology or the compact fluorescent light bulbs. They cost more initially, they do last a lot longer, and again, there's always a trade-off because there is some concern over the long-term disposal of the compact fluorescents. They do contain a little more toxic substances than the old incandescent light bulbs, but again, they use substantially less energy. So ultimately, we're trying to develop alternative energy sources to power our homes, and again, we can each individually look at ways we can reduce energy, turning things off when we're not in rooms, for example, unplugging things when we're not using them. So, because we consume so much energy, certainly there are alternative ways of considering our energy use. Certainly, there's the direct solar energy, basically the heat from the sun that reaches the surface of the earth. We can basically utilize the construction of our home, when we open the blinds in the summer and the winter time to let the sun's energy kind of warm up our house, and conversely then shutting the blinds in the summer before the sun's energy starts heating up our house. The downside, of course, whether it's direct solar or some of the indirect technologies, the sun isn't always available. If you live in a place like Redding, we have a lot of sunny days each year. California in general, places like Arizona, Florida, but a lot of the country doesn't have as consistent sun. However, that doesn't mean that various forms of solar energy can't be utilized a lot more than they are now. And again, although we use basically the sun's energy itself, most of the forms of solar energy that we try to harvest have to be collected and then transformed into a type of energy that we can use, typically to power electrical things. So active solar heating involves basically collectors that absorb the sun's energy and then a series of pumps and fans that distribute that collected energy as heat that then is circulated through the house. And typically right now that's used basically for heating water. And honestly, when you look at a typical household, a lot of our energy is used for heating water, doing dishes, doing clothes, taking showers. Those kinds of things account for a lot of energy. And then whether our hot water heater is gas or electric also makes a huge difference. But also in areas where there's a lot of swimming pools, the solar energy can be used to heat those as well. And basically, if a system is set up, a big enough system is set up, you can have hot water year-round, even in colder climate areas. And again, when more than 8% of our energy goes towards heating water, that's one area where every one of us could consider making a change. Using enough of a solar grid just to power your hot water heater isn't nearly as expensive, obviously, as a whole house solar system. So again, just the relatively small amount of money that we would need to invest in a hot water heating solar setup could easily pay itself back in a relatively short amount of time. As gas and oil prices and electricity prices rise, then there will probably be a greater demand for some of the whole house type solar systems that are used to heat and cool a home. But again, at least providing solar power for water heating would be a huge step in the right direction. And again, we could accomplish this by requiring that new construction, or at least maybe new construction in urban areas, have to have some level of solar. And the more that that's incorporated in new construction, the more likely that's going to continue to drive prices down and take away of some of the demand in the large urban areas where obviously the most electricity is being used. So just a diagram of active solar heating so you can kind of get a visual sense on how that process might work. Passive solar heating doesn't actually require any mechanical devices. This is basically what I was talking about earlier. If you have a south-facing window in your home and it's the winter time and it's sunny out and you open up the curtains, the house warms up naturally because of the sun's energy. And especially in the winter time in the northern hemisphere, the sun's lower on the horizon, so more of that sun's energy can make it through and then warm up your furniture, your floors, your walls. And basically it's just heat being transmitted by convection. Of course, having good insulation and double or triple pane windows certainly will help maintain some of that warmth inside the home. And then, as I mentioned, conversely, you don't want that passive heating in the summertime, so just keeping your blinds shut or planting vegetation on the south side of your house that leafs out in the summertime can help shade that side of the house to minimize the amount of passive solar heating that you would get in the summertime. And basically, even just passive heating can save up to 80% of heating cost in the summertime, if, of course, you live in an area where you do have a fair amount of sunshine. The farther north you get, and the colder it gets, and the more days of cloudy weather you have, obviously, the less effective that's going to be. This is another area where we could do just so much more than we are. Only about 7% of new homes built have sort of accommodations for passive heating. In other words, orienting the home so that a lot of it is facing north and south, large windows on the south side of the home, so that again you can take full advantage in the winter time. Again, that's not earth-shattering kind of technology. It's just orienting the home, using large and well-insulated windows, landscaping appropriately. That alone, again, could save up to 80% of your heating cost in the winter time. Here's an example of a home that's completely designed around passive solar heating. So it's, again, a south-facing home, lots of big windows. A lot of the house you can see is actually underground. Maybe you can't quite tell from looking at the image. But a lot of the home is buried underground, so obviously that's great insulation. And then, of course, there's photovoltaic cells, basically what we think of as solar panels, which are fairly thin films of materials that are treated with different metals that ultimately can generate electricity when the sun's energy is absorbed into them. So it's basically taking that sun's energy and converting it into electricity. Ultimately, while you're using it anyway, there's no pollution, there's minimal maintenance. Now these panels are being built to last 30 plus years. Used to be they'd get oxidized, they'd start kind of getting cloudy looking, and they'd get less and less efficient that way. But now they're being built with much better materials that last so much longer. Again, you do have ultimately when they do die or go bad that you do have to dispose of them, and that certainly can be material that's going into landfill. But in the meantime, you're generating clean energy. And even on cloudy days or rainy days, if there is any light outside, it doesn't have to be direct sunlight. You are still generating electricity, although, of course, the amount of electricity being generated goes down the cloudier it gets. They're still relatively low efficiency, and so in a home, if there are solar panels on the roof or in the yard, that's one thing, but a lot of the really large scale power generation isn't in place because it requires so much land to generate enough electricity to make it sort of worthwhile. And then, of course, that energy has to be transmitted however far away, the city or whatever is. However, it can definitely be economical in rural areas versus, installing power lines everywhere. A friend of mine had built a house kind of at the end of a road, and the power, when he bought the property, the power hadn't been PG&E, in other words, hadn't had power poles all the way out to his property and where he was going to build his home. And so between pricing what it would cost for PG&E to run power out to his home, comparing that to what it would have cost him to do a whole house solar system, including batteries for backup when it was cloudy, it was about the same price. So you figure if you're going to spend $20,000 anyway, then why not go solar? Because again, it can be completely dependable, meet all of your needs. You don't have to skimp on, turning lights on or off, or it runs air conditioning. And the best thing of all, of course, we all know, right? No power bill, ever. So it was pretty much a given, a no-brainer that that's the way he went. So definitely in rural areas, cost of running power out to a home versus just going with a whole house solar system, it's really a no-brainer, because again, you're not paying monthly bills, and you pretty much have as much energy as you probably need. The good thing is that the price of manufacturing photovoltaic cells has continued to decrease over the last 30 plus years, and now the technology is such that they can even be incorporated into shingles on the roofing tiles, and so they don't stand out and don't look ugly. That the issue a lot of people have had, is they don't want solar panels on the roof because they don't look nice. Well, again, now they're really being incorporated right into shingles, so they're just part of construction now. California, when Arnold Schwarzenegger was governor, had tried to get an initiative going that a certain percentage of homes, new homes, that were being built would have to have photovoltaic technology incorporated in them, and then that kind of just went away. People are doing it on their own, but had it become a law or a requirement, that certainly would have continued to increase. Japan is actually considering a similar policy, basically requiring photovoltaics on all new building rooftops by 2030. again, as much as people are doing this on their own, it is still, a bit expensive. And if it were incorporated in new construction, it'd be incorporated in the mortgage. And again, it would just become the norm instead of the way it is now. Here's an example of the PV technology that basically looks just like shingles, and so it doesn't stand out as much on a roof, and yet again it's every bit as efficient as any other photovoltaic cell. One of the things that a lot of people still point to, of course, and this is the reason we haven't gone more heavily into some of the other technologies, is if you look at the cost of generating electricity using these different sources of energy, what's the most expensive on the list? Photovoltaics. And then solar, thermal is still fairly high. You look at natural gas, coal, and how relatively inexpensive those are, the non-renewable resources. Although wind, geothermal, biomass, hydropower are all in that same realm. So then again, what is really the reason that we haven't gone from using the non-renewables like coal and natural gas to using some of the others? Well, in the case of photovoltaics, it's the cost. You have to have a fairly large electrical bill every month for the cost of the solar system to pay for itself in a reasonable amount of time. I checked into it for our place. We only have an electric bill of around $100 a month in the summertime, and it's half that the rest of the year. So for the cost of a full house solar system, our electricity bill is just so low on average that it just wouldn't be able to pay for itself for 10 plus years. And again, some of the other technologies are as cheap or even cheaper, like wind, but when we get to that a little later in this section, we'll talk about why we haven't gone more in the direction of using things like wind. So again, the solar thermal electrical generation is definitely a proven technology. It's efficient. Again, relatively speaking, it's more expensive, but it also definitely has the big positive of not generating pollution. So again, we've got to kind of decide: do we want to pay less for energy that pollutes the environment, or do we want to pay more for energy that is basically clean energy? That's, again, our ongoing challenge. In the large sort of industrial scale production facilities like we see here, notice the mirrors are curved, and they actually, you can see the fluid-filled pipes that run kind of along the middle of the curvature. So the sun's energy is even more concentrated and pinpointed back at those fluid-filled pipes, where basically that water is then boiled and steam is produced that spins turbines that makes the electricity. And these kinds of systems that even track the sun throughout the day to be most efficient at, for the longest period of time are becoming more cost competitive with fossil fuels. And again, if they are then comparable price but create no pollution or don't affect climate and don't create acid deposition, and we don't have to use a non-renewable resource, then then how can we not be interested in going more in this direction? Other than it's that, again, back to the first or second week of the semester, not in my backyard. People don't want to see these things because they don't like the way they look. We've got to get over that, though. Again, I don't care how it looks. We should care about the air we breathe and the water we drink more than how something like this looks. I actually, when I see these things, I don't think they look pretty. Of course, I'm not that weird. But it gives me a sense of a positive feeling, because I get to think how much energy is being generated by this facility, clean energy, that's one less natural gas burning power plant that we have to build, less pollution, less environmental degradation. So again, there always is going to be trade-offs, but ultimately we've got to decide what we value more, clean environment or cheaper prices. There's also solar generated hydrogen fuel, which a lot of people believe is going to be the fuel of the future. And I agree, because it's abundant, it's easy to produce. Again, it doesn't create any bad output. Hydrogen itself is a clean fuel because it just produces water and heat as byproducts, no other nasty things. But we go back to when the second George Bush was president. He said in the next 10 years, hydrogen fuel is going to be more common. Hydrogen vehicles were being developed. And then all of a sudden, we just quit. And now we have electric vehicles everywhere. We went to the hybrids, like the Prius, those kinds of things. And now all of a sudden, when we thought the electric vehicles were dead, now all of a sudden electrical vehicles are dominating the landscape. Every manufacturer actually has them for sale. And we don't even talk about hydrogen anymore. Again, there's positives and negatives with electric vehicles. If you ignore the range or any of that stuff, do electric vehicles make any emission when you're driving it down the road? No. So that's great. You don't create pollution when you're actually driving the car on the road. But what happens when you go home and plug it in? Where is that electricity coming from? Unless you have your own solar array on your home, that electricity is most likely coming from a non-renewable resource. You're getting energy from coal or natural gas in a lot of cases. So you're still generating pollutants to charge up your car. Whereas again, if we were generating hydrogen, then that would be one less source of pollution that we'd be creating. So there's talk again, and there's some renewed interest in hydrogen. But I just find it interesting that we killed electric vehicles back in the 70s, and then hydrogen was the next greatest thing that was going to be everywhere by the 90s, and then all of a sudden in the 2000s we're back to electric vehicles. So the use of hydrogen isn't without problems, of course. It is a potential source of energy for everything we use energy for. But the electricity has to be used immediately. For the typical electricity that we use now, when it's generated, it's either used or it's gone, whereas hydrogen can actually be stored. Again, the downside is that if we're burning fossil fuels to make hydrogen, then we're no better off than we are now using electric vehicles. But if the hydrogen is being generated by solar or wind or geothermal or some other renewable source of energy, then there really isn't any downside. Right now we generate hydrogen the easy way by using other non-renewable resources to make it. But when we truly get renewable, there's really no downside to hydrogen. And another huge upside is almost any vehicle we drive today. I don't think diesel vehicles can be, but gas-burning vehicles can pretty easily be converted to burn hydrogen. And then, of course, there are vehicles that are built ground up to burn hydrogen. So, again, your book gets into hydrogen production, and basically it's a relatively low efficiency process, and it can be high cost. Which again is kind of the downside now. Replacing hydrogen as our primary transportation fuel does have some other costs. These are the same costs that the gas and diesel industry went through when it first started being built. I mean, there's a lot of infrastructure. Gas stations as they are now would have to be totally rebuilt to handle hydrogen, so there would be a lot of cost. And ultimately, the way it works in other countries is every individual fueling station makes its own hydrogen on site. Hydrogen is flammable, and fuel cells have to be developed for the motor vehicles that are kind of like batteries. They store energy. Actually, they're storing or producing energy as long as it's being supplied with hydrogen, but it's kind of a similar idea to a battery. And like photovoltaics, the fuel cell cost has dropped a lot, but they're still fairly expensive. And again, in reality, they're going to remain expensive until it becomes a much more common technology. It's that chicken or the egg problem. If you build a bunch of hydrogen vehicles and you've got 6 fueling stations in the entire state of California and you don't happen to live anywhere near one, you're not going to buy a hydrogen vehicle. If a bunch of hydrogen fueling stations are built before the hydrogen vehicles come into the market, then they're going to go broke and quit. So these things kind of have to happen at the same time for this to work. Again, I think maybe some of you remember Arnold Schwarzenegger driving around his Hummer that had been modified to use hydrogen. And, he was fueling it up in, I forget exactly where, the Bay Area or Los Angeles, something like that. But again, if the technology is utilized more heavily, it's already there, it works, there aren't any real problems with it. It is flammable, but the way it's contained in the fuel cells, it really isn't a problem any more than gasoline is in an automobile if you get in an accident. So more of that is just fear of sort of not really knowing it because it's not our type of fuel right now. We use gas and diesel or electric vehicles. We don't use hydrogen, so we've got some concerns about it. But again, ultimately, if you look at other countries that use it, a fueling station makes its own hydrogen, and think how much cost ultimately that will save. Where does our gasoline come from now? Again, a lot of it comes from elsewhere in the world. It's pumped out of the ground, it's shipped across the world, it's refined, and then it's still trucked everywhere else in the country to the fueling stations. All of those things cost money to do. If the hydrogen is created right at the fueling station, there's no transportation cost, no additional cost to get it from where it's made to where it's used. But again, it's all going to have to happen at the same time. A lot of the less developed countries depend on indirect solar energy. Basically, they depend on combusting organic materials. So basically, again, the sun's energy allows plants to grow. And then in places, less developed countries, that plant material is collected and burnt to cook food, to heat homes, pretty much everything that those countries depend on. Wind energy uses the wind, obviously, to generate electricity, just as hydropower uses water to spin turbines to generate electricity. Again, these latter two types of energy are developed throughout the world, but still very, very small amounts of our energy comes from these truly renewable sources, wind and hydropower. Even though a lot of the less developed countries use the indirect solar energy, burning, organic material, we still do in this country as well. We don't typically depend on it as much as people in the less developed world do, but a lot of us still, get firewood every year and maybe heat our home partly or completely with firewood. It's a cheaper source of energy for those of us that have that sort of a setup, or have enough land that we can harvest our own firewood, or we buy it from someone else. But we can also use it in the bigger scale, burning waste material to generate energy that can be used to provide electricity, especially for homes in rural areas. And of course, burning plant material can be a completely renewable source of energy. So it can be another example of a renewable energy source, as long as it's done properly. At least half of the world relies on biomass, and primarily being wood for cooking and heating homes in a lot of those developing countries like I was talking about. But crop wastes, sawdust or wood waste, charcoal, peat, animal dung are all examples of other types of biomass that are burnt to generate energy. A facility like Sierra Pacific, all of the sawdust that's generated from cutting wood and all of the scrap pieces of wood and bark are all caught on a conveyor belt system that runs back to a biomass plant where they burn it and generate electricity that provides most, if not all, of the needs for the sawmill. So it's kind of a self-sustaining process. They don't need any external energy to power their sawmill. One more thought on biomass. There have been a lot of proposals to build biomass plants throughout California, especially in some of the rural communities where there's a lot of forestry going on. And so all of that wood waste that isn't usable for timber products can be taken to those biomass plants where it's burnt for generating electricity, and again can provide a fairly cheap source of energy and jobs, obviously, for those rural communities. But there are a lot of problems that are being addressed. There's always going to be the air pollution issue, although a well-engineered biomass plant doesn't produce much pollution. And then, unfortunately, you get a lot of some of the more radical environmental groups that, instead of looking at the benefits of having a place where the waste products can be burnt and relatively cheap, clean energy can be generated, they look at it sometimes as a way that we're just trying to justify doing forest management. There's so much of our forests that we've talked about that are too thick. And some of the stuff that we would thin from those forests to make them healthier is too small to really make timber products out of, so we could just burn it for energy. But again, there are some legal battles going on around the state that have limited most of the new biomass plants that were being planned. Another indirect type of solar energy is biogas, where basically you have biomass that's being converted into a mixture of gases, mostly methane, and then basically this gas can then be burnt like any other gas would be burnt to make heat or energy for cooking. Has the potential to power fuel cells to generate electricity. There was a pilot in the United States in Boston in 97 that basically allowed enough energy to be produced to provide electricity for 150 homes just from sewage, sludge that was collected. Again, it would require some different sort of infrastructure, but we know we generate a lot of waste in this country and around the world, and just another example of a possible way to utilize a waste product that we generate to make energy. So these other liquid fuels that can be generated as well, like methanol, ethanol, and biodiesel, have all been looked at over the last couple of decades as opportunities maybe to replace gasoline, or biodiesel that can be made from plant or animal oils that could replace the petroleum-based diesel fuel. The good thing about biodiesel is that it really doesn't require anything special to just pour it in a diesel-powered vehicle's tank. Diesel engines can basically just combust vegetable oil, or they talk about the waste oil from, say, McDonald's. As long as you strain all the chicken nugget scraps out of there, it can be combusted as it is. There's some downsides with ethanol as far as replacing gasoline. Biggest downside and the reason that we've already kind of gotten away from using it is we typically would grow a crop like corn, and then that corn would be converted into ethanol or methanol, that kind of fuel. The problem, of course, then is the more land we devote to growing a fuel as opposed to a food, whether we eat the food or we feed it to livestock, the less food there's going to be. So if you look at the amount of demand we have for gasoline, fuel in other words, there just isn't enough land to grow enough corn or whatever product we choose to grow and still have enough land to grow enough food for us or for livestock. And so ultimately it started kind of driving the price up. Livestock feed was getting more expensive. Therefore meat was getting more expensive for us to buy. And so we've kind of gotten away from that a little bit, although it's still it's still one of those things that politicians and even consumers are looking at as a source of energy. Again, the challenge is we don't often understand kind of the consequences necessarily of something like this. If you look at the amount of corn or other crop we'd have to grow to make enough fuel to really matter for a country like the United States, where would we get feed from for our livestock and for us? One of the staple items like corn would get really, really expensive, or we'd have to buy more and more from other countries. We might get independent of fuel, but then we'd get dependent on something else that's just as important in a lot of ways. So again, the problems, as I just highlighted, basically using land and water for that instead of food production, converting crops that would be used to produce ethanol, definitely drive the food prices up and reduce the food supplies. It really is an unsustainable way of using wood, for example, because there would have to be so much more volume of wood to be used for fuel production, and therefore far more damage than would typically be generated by using wood as we currently do for timber production. Therefore, that greater demand for wood would create a greater damage to the environment. All the problems we try to avoid now would probably get worse. And so ultimately, harming the soil, those kinds of things, because we wouldn't be leaving crop residue behind like we argued we should in an earlier chapter. So other than solar energy, which is still fairly expensive but has a lot of capability of meeting our needs in the future, the other big one that we would look at is wind energy. Electricity obtained from basically converting currents of air on the surface of the earth to electricity. And we're not talking about just little windmills like you might have in your backyard. We're talking about huge wind turbines that are in excess of 200 plus feet tall. Each of the blades of the windmills, like we see in the background here, are around 100 feet, 30 meters roughly, something like that. So just huge windmills that are even more efficient than they used to be. Again, in that 4 to 7 cent per kilowatt range now, which is competitive, if not even just a hair cheaper than coal or natural gas. Definitely the most competitive renewable source of energy, competitive with respect to the conventional types of energy we use. And just like the sun's energy, obviously it's more effective in areas with consistent winds, just like solar is more efficient when you're in an area where there's consistent sunlight. So coastal areas, because of the ocean, onshore breeze, mountain passes, Areas where the mountains kind of dip down are funnels that push the wind through at higher velocity. But even on islands, literally because they're surrounded by the ocean, so you've got those constant winds. And then open areas, open grassland areas throughout the heartland of our country. In California, the Tehachapi Pass has the highest concentration of wind turbines. And basically, aside from the U.S., countries like Germany and Denmark are producing more of their energy through wind. Denmark produces about 21% of its energy by wind, which is substantially more than the United States. China is also expanding its wind energy capacity as they are continuing to develop and become more industrialized. So again, just kind of a chart showing the world wind energy generation capacity. And we can see how the capacity has gone from almost zero prior to the 90s to now in excess of 200,000 megawatts. 200,000 megawatts. If I'm reading, actually it's 200,000 megawatts. So the numbers on the graph are times 1,000 megawatts. And again, you can just see kind of a close-up of the actual turbine. Simplified, of course, but the general idea. The wind spins a propeller. The gearbox drives the drive shaft that spins the generator that makes electricity. Around the country, there are certainly states that have a greater potential because of wind patterns. Some of the northern tier states, the Dakotas, Montana, Wyoming, Texas, Oklahoma, areas where there are constant winds. If we just developed wind energy in North Dakota, Texas, and Kansas alone, if we fully developed those three states to their capacity, which, by the way, wouldn't mean, that you would have a wind turbine every 100 feet in the whole state, but if they were placed in areas where the wind is most concentrated, that alone would be enough to supply electricity for the entire United States. And there are a lot of newer projects that are underway, like our one up at Hatchet Summit that's a couple years old now. Of course, that's not practical because the energy would have to be shipped, from Texas all the way to California or from North Dakota all the way to New York. But again, the point is that there is more than enough potential for wind energy, more than we're utilizing it today. Again, the challenge would be the energy would have to be captured and put into regional grids of electricity, and we would need to have a better way of distributing that energy. As energy goes down a power line, it's lost. Some of it's lost. So the farther it has to travel from where it's made to where it's used, the more it's lost. So that's always an issue, but one that we continue to look at solutions to. It is, again, pretty much a no-waste, clean source of energy. And every kilowatt of wind energy that's produced reduces the release of about 2 pounds of CO2 as would have been released by the equivalent amount of energy being generated by fossil fuels. Even more than solar power, if a wind turbine, breaks down or its life is over and it has to be torn down, there really aren't any toxic elements that have to be dealt with, and probably, some of the stuff can even be recycled and reused, which isn't different for solar power either, as far as the potential for some of that to be, repurposed. Of course, there are real and perceived problems with wind turbines. There's a lot of research that's constantly going on regarding the effect of these turbines on killing birds, especially when they're in the sort of the migrational pathways of birds. The Altamont Pass in California is an area that's kind of under scrutiny. because there have been bird kills and even eagles, for example. Some of these things can be dealt with by basically not putting turbines in areas that are critical for wildlife migrations, so we can avoid certain areas that we know are heavily used by migrating birds. The blades can be made higher visibility, things that are used to keep birds from perching on them, even slowing down the speed of the turbines during the peak migration period. A lot of research is being done again, and there's even research that's ongoing up at the ch18 wind farm. A couple of my former students have assisted with the research up there. One thing that a lot of people don't understand is there definitely are birds that are killed by these things, and typically it's overnight when you've got birds migrating through in the dark. They don't really see the blades if they're moving, and they run into them. But a lot of people have this notion that these turbines are moving like a propeller on an airplane. And even with pretty strong winds, the propellers are moving relatively slow. So again, you do get bird strikes, but it's not like an airplane propeller up there, chopping things up. So there definitely are things that are being addressed and technologies that we're looking at that minimize the chance of bird kills. But before we go on to the other and probably bigger problem, there are a lot of environmental groups that don't want wind farms because of the potential for bird kills. So you've even got environmental groups fighting a clean source of energy. Now, again, to make sure you understand the full picture, do birds die by any other means that is caused by humans? How many of you have ever hit a bird or any other animal with your car? If you drive up I-5 between here and Sacramento any given day and you watch really closely, I bet you will see a lot of dead birds, especially things like barn owls that are hit by automobiles. How many have ever had a bird fly into a window of your house? Probably most of us have, if you think about it. I have that happen occasionally here, a couple times a year probably. Occasionally they hit real hard and it kills them. A lot of time they bounce off it, recover, and are fine. And then the big one. So where does most of our energy come from now? From whether it's coal or anything else, it gets transmitted through a power line, right? Do birds ever get electrocuted on power lines? And of course the answer is yes. So I just find it frustrating that you'll have environmental groups fighting a clean energy source like wind and not going on a bender to fix some of the other problems. We could manufacture windows so they aren't reflective like they are, or some way, find technology that makes them less likely to cause birds to fly into them. We could, have our power lines better insulated. Maybe they could run underground through conduit, so there's zero chance of electrocution. Again, why fight a clean energy source when there are a lot of other things that create a lot more wildlife damage than wind turbines? But with that said, the bigger issue, the reason probably that we don't have more wind farms is because people don't like the way they look. Just like we don't really like looking at a solar panel on a roof of a house or a bunch of solar panels out in our backyard, we really don't like wind turbines out in the landscape. There was a wind farm that was going to be built in upstate New York, and basically the residents would actually benefit getting a little extra money because they would be being paid for their land to be leased, and this is really a huge positive. If you're a farmer or rancher and you're in an area where there's, consistent enough wind, you could actually get paid monthly just for the wind turbine to be on your property. And that in some cases people have looked at as sort of their retirement, that is going to be consistent and a good source of income. And again, keep in mind, they can still graze cattle under those things. There's a footprint, obviously, but there still is going to be a lot of open space under there that they can continue to utilize their land. But the other side is that so many other people complained, especially all of the really wealthy people in that region, that basically they didn't want the turbines to ruin their view. There was another proposal. Again, we talk about, being near the ocean is good for wind because there's pretty much always an onshore breeze. There were proposals to place the wind farms offshore, out in the ocean, and then the energy would be, connected to the land by cables that would be on the ocean floor. So the thought is great, they're out in the ocean, generating lots of wind, and they're not in people's view. Again, the proposal was in an area where there were a lot of very wealthy people, and they didn't want to see the wind turbines out in the ocean because they would, they didn't like the way it looked. They believed that tourists wouldn't come to the area anymore because they would see the wind turbines out there in the ocean and just be disgusted by how ugly it was. Again, unfortunately, a lot of ignorance here. A lot of people had the same complaints in Redding about the Hatchet Mountain wind farm. And you can see it from Redding in certain areas if you're looking for it, but it's not that visible. I mean, I can see it from my house. I'm about halfway between Redding and a little less than halfway between Redding and the wind farm. Again, I can see it from a couple places on my property. But in general, as far away as Redding, people really would have to be much more observant than they usually are to even notice it's up there. One country, I think Scandinavian country, actually, and I think maybe I'll even talk about this again later, I don't remember for sure, looked at putting the equivalent to like a wind turbine under the ocean. And then basically, instead of being powered by the wind, it's powered by the ocean currents. So they've actually installed a number of those underwater. Of course, the environmental groups are worried about interfering with, marine mammals and fish. But again, they're relatively slow-moving by ocean currents, and there is technology, again, to just kind of deter the animals or fish from getting close enough to them. So lots and lots of solutions, lots of possible capacity that we could use in the future, but there are still real problems and some that are more aesthetic, that people just don't want to see them. I'm not sure what those people think we're going to do in the future. They don't want to see a wind farm. They don't want to see solar panels. They don't want a new power plant built next to their house. They just kind of want things to be out of sight. And again, that's not going to work forever. We've got to just make some concessions. Another clean energy is hydropower. We've probably at this point really maxed our potential for hydropower. There are a few larger dams being built in other places in the world, but most of the larger rivers have already been dammed up. So hydropower is, again, a form of renewable energy that relies on the flow of water, the movement of water to spin turbines and make electricity. It requires, obviously, some substantial alteration to the environment because of the need to build a dam. It is pretty efficient, though, than many other sources of energy. About 90% of the potential energy is actually converted to electricity. So that's a pretty high efficiency rate. Worldwide, hydropower is used for about 19% of the world's electricity, but only about 7% in the US. And again, because we just don't have any other big rivers that can be dammed up, the percentage in the U.S. probably is not going to change. If anything, it might start going down if we start taking dams out for the benefit of the environment. As I mentioned, dams are required to be built to harness hydropower, and they are the biggest problem because they completely change the natural flow of the river system that they dam up. The water backs up, it floods big areas, of course, creates large lakes instead of rivers. It can benefit some animals, but also and fish and reptiles and amphibians, but it can also destroy other habitat, so a bit of a trade-off. The areas downstream don't get the same nutrient cycling that they used to because they don't get the free-flowing water going downriver. Again, dams don't look pretty, but again, people don't seem to complain about them as much as they do other things, like solar and wind power. They have to definitely be engineered to be safe, and in California and other areas where there are earthquakes, seismic activity, fault zones, those kinds of things, they do have to be engineered to withstand those things, because if the dam were damaged substantially in an earthquake, it could obviously kill a lot of people downstream if it broke. We also have the problem that when you make a dam and you store a bunch of water, especially if you're in a hot, dry climate like Redding is in the summer, you lose a lot of water just to evaporation. And so you're storing a lot of water, but you're also losing a lot of water because of this big reservoir you've created. And again, there are some other challenges as well. Another benefit is, like for Shasta Dam, it creates Shasta Lake, which is a opportunity for recreation. So again, there are positives besides the relatively cheap energy that they produce. But usually the environmental damage is the bigger issue. In areas that have a lot of activity, a lot of geothermal activity, it actually can be used for generating electricity. About 1% of the heat contained in the uppermost layer of the Earth's crust is 500 times the energy contained in all of the Earth's oil and natural gas resources. So again, basically what we're saying here is that the potential just heat generated by the Earth, geothermal-wise, is 500 times more, substantially more than all of the energy contained within the crude oil, natural gas, for example. So a lot of potential, in other words. Anytime you have volcanic activity, you heat the underground water, and then that water escapes to the surface, either as steam or in hot springs. And again, you can have boiling water or steam that spins turbines that makes electricity. And it is pretty inexpensive, and it's definitely reliable in areas where there is consistent geothermal activity. Maybe surprisingly, the United States is the largest producer of geothermal electricity. There are other countries in the world that depend on it more, but overall we have the greatest production. Just the Geysers geothermal plant in California produces about enough electricity to supply just under 2 million consumers. And this is the one, I think, that's kind of south of the Clear Lake area. Iceland, one of those other countries, because it's a volcanic island, actually heats about 66% of its homes with geothermal. So again, that country uses it pretty heavily, and they even, because of how cold they are, actually, I'm sorry, the one in the background here, I think, is the one in Iceland. They actually use geothermal energy to heat greenhouses, even in the winter time, because of how long their winters are, to grow fruit and vegetable year-round. So they can even generate some fresh foods at times of the year when otherwise they would have to depend on buying it from other countries in the world. And of course, geothermal energy is renewable resources, at least on the human time scale, because basically the water that's being produced to make the energy is not inexhaustible, but it's abundant enough that basically it's not likely to run out. And basically, again, it's considered a neutral sort of environmental energy source. Again, the downside is that not everywhere has enough geothermal activity to really tap into it. So like with wind, you're only going to put wind farms where there's enough wind all of the time. You're only going to put solar panels in areas where there's enough sun for enough of the year. So the same thing with geothermal. This slide talks about the basically taking advantage of the difference in the temperature between the surface of the Earth and the subsurface. You can actually, use the temperature below the soil to warm a house in the winter because it might be warmer underground in the winter, or you can tap into cooler air that might be below the surface in the summertime. Fairly expensive to install these systems, but really cheap to run them. And again, the more that we use this green architecture, incorporating these kinds of renewable energy sources into our homes, the more popular they're going to get, and ultimately the cheaper they're going to get. A couple other things that are used, but generally speaking, pretty small amounts. We can use the tide in the oceans. We know there are times when the tide is high and times when the tide's low. So basically we can identify areas along the coast and be able to dam up a bay and then basically harness the energy of areas where there's a big enough difference between high and low tide. So you think about the dam like on a river, it's one way. Water flows from upriver through the dam, spins turbines, goes downriver. So it only generates energy as it's going downriver. A dam out in the bay of an ocean, imagine you shut the dam up so you don't let water go through. As the ocean is going to high tide, once it kind of reaches its maximum level outside of the bay, then you open up the dam, the water flows into the bay through the dam, spinning turbines, making electricity. And then once that water has filled, then you shut the dam, so it's holding the highest level of water, the high tide volume inside the dam in the bay. You shut the dam, and then when you get to the lowest tide on the outside of the dam, you open up the dam again, and now you generate electricity again, except the water is going from the bay back out to the ocean. So theoretically then, twice a day, you can generate electricity going both directions to spin turbines to make electricity. Again, there are problems because there aren't a lot of places in the world that have a big enough tide to really make the cost, to make it cost effective to do that. Again, just like a dam in a river system, it's environmentally a very costly process because of the potential damage you can do to that coastal marine environment. So again, you got to find the right conditions to make it work. So now finally, the last couple of slides. What can we do to fix the problem? Really, there are two main solutions. We can either get more conservation minded, use less energy, and make less waste. And the other option is be more efficient, use less energy to accomplish a given task. So we can conserve energy and become more efficient with our use of energy, more efficient technology, more efficient appliances in our homes, for example. So even though the U.S. has become far more energy efficient, consumption has still increased because there are more of us than there were. So even though we are more environmentally conscious and we're more efficient, if there are more of us, just as a total amount, we use more energy. And this is true pretty much of developing nations in general. Even though our per capita consumption is greater in the developed countries like the U.S. than the developing countries. But like we talked about in the previous chapter, those developing countries, even though their per capita consumption is less now, the more that they become industrialized, the more that their rate of consumption, per capita consumption, is going to grow. And again, especially in countries like China and India, the rate of their consumption is continuing to grow. And as more and more of the country develops, and as they use more cars, and as they use electricity more and more, then that's going to create a greater demand. And not only is it a problem that there are just a lot of people in those countries and they're using energy, but like we talked about again, they're going to use coal to make electricity, the most polluting non-renewable resource. And they're also going to use the older and less expensive technologies. So again, the less efficient technologies that we did away with, they're going to continue to use because they are cheaper. So it's going to be that need to balance economic development with how much they degrade the environment. So some of the energy efficient technologies that we can or can continue to improve upon in the United States. So earlier in the chapter, we mentioned the compact fluorescent light bulbs that basically produce a comparable amount of light to an incandescent light bulb, but only about a quarter of the energy, and they last longer, even though they're more expensive. So you're using less energy and they last longer. Different furnace technologies that require less fuel to make, again, equivalent amount of heats. What's termed as super insulated buildings that can use up to 90% less energy than the standard sort of insulation and glass and materials that we typically use. So again, there are a lot of solutions that can just be incorporated in all new construction of homes. And then, of course, many of these same technologies could be retrofitted into other homes. So again, just an example here, this image, having a very thick concrete foundation, few to no windows on most of the building other than the south side, having smaller, more efficient furnace or air conditioning, or even using the air-to-air heat exchanger that provides ventilation and better air quality inside your home, filtering out all the nasty things that can be in our home. Using, again, really good insulation on the walls, floors, ceilings. Incorporating, again, solar shingles. Having gray water storage that can be used for watering lawns. Having water storage tanks that can capture rainwater to be used for drinking. There's just so many things that we can either do individually or that, more importantly probably, could be incorporated in every new home. If every new home that was built in the Los Angeles area was completely self-sufficient, in other words, they had to have solar panels and there were underground water tanks that captured the gray water that was used to water their lawns, even those two things, if they didn't add more strain on the energy grid we already have, that would go a long ways towards kind of helping the overall air quality of California. Things like appliances have gotten so much more efficient, about 80% less energy than they did 40 years ago. buying energy efficient appliances to replace your old ones when they break is just one thing we all can do. I mean, by default, if you have a 30-year-old refrigerator, and even if you buy the cheapest one that you can today, it's going to be substantially more energy efficient. Things that are even 10 years old are not nearly as efficient as the technology we have today. So any of the appliances that you replace are going to demand less energy. Certainly automobiles have become way more efficient and much less polluting than they were in the past. Fuel efficiency has doubled between the 70s and 80s. It kind of declined quite a bit after that because of the demand for all the big SUVs. But it's probably going to be pretty common that automobiles are going to be in the 60 plus mile per gallon range in the next decade or so. I mean, there already are cars that'll get that kind of mileage, but it's going to continue to get better than it is today. I mean, I've got a sports car that's about 10 years old. It's got a big V8 engine. It's got a lot of horsepower, but I still get 30 miles to a gallon on the highway, and average maybe 25 going back and forth to work. So just thinking about that car compared to a similar car that was maybe 20 years older, it probably would get a third of the gas mileage, just like those big SUVs. 10, 12 miles to a gallon was pretty typical. Now, again, even the big SUVs are easily double that. We've talked about the biomass plants, basically, using more biomass and cogeneration to burn our waste products instead of dumping them into landfills and making energy is something we're not nearly taking advantage of as much as we could and should. And again, there are environmental concerns and some other more political challenges, I guess, to why we don't do this more. But we've got a huge potential here to make a lot of energy, especially, again, for rural communities and jobs for rural communities by just burning waste products. So the Enviro discovery near the end of the chapter talks about, gathering the benefits of home energy production. Even aside from home solar systems, if you're in an area where you've got at least occasional breeze or evening winds, even just having a smaller wind turbine could pay for itself over the course of time. Again, the problem most of us have is that's kind of expensive, and so you pay quite a bit of money, and you don't know how long it's going to take to kind of break even. It might be 5 years, might be 10 years, but utility companies now are even giving more incentives to doing this. In that, in the summertime in Reading, you're going to generate more energy than you need if you're got a solar system on your home. But again, there's really no way to store that energy. It's either used or it goes away. But there are again, PG&E, for example, if you're making more energy than you're using, say by generating solar energy in the summer, you might see that your utility meter starts going backwards. In other words, you're putting energy out into the grid that maybe somebody else is going to be able to use. So although PG&E doesn't pay you for it, you can build up a credit if your meter is running backwards, so that maybe in the wintertime, maybe there's 3 weeks in a row where we're in the clouds and it's raining, and you're not generating enough solar energy to meet your needs. Now your meter starts running the other way, and you're taking energy off the grid. But again, you might be using your credits, not, again, having to pay anything. And so that makes it more appealing to people, because maybe they go, in some cases, a bigger house, or maybe you're paying $1,000 a month in the summertime. Now, with the solar system, you might be paying nothing. $1,000 a month times 12 months, even if you pay a little bit, you lose a little bit, you get a little credit, you use a little credit, you could maybe pay for a system like that in 3 to 5 years. And then after that, you're not paying the utility company anything. So you're saving $1,000 a month that you could then invest in something else. So this makes it more affordable when there are rebates, like there have been, incentives to get wind or solar, and again, you can sort of bank the energy for when you might need it at other times. Even electric companies have to become more energy efficient. There have been a lot of changes in regulations that allow electric utilities to make more money by generating less electricity and providing incentives for conservation, which ultimately is the point is to reduce the emissions, because again, most of this energy is being generated by burning fossil fuels. So they're basically trying to help the environment, and then yet they get incentives and can actually make money if they help consumers save energy. Basically, they're discouraging from building new power plants because you can be more efficient. Again, there are cash awards, free compact fluorescent light bulbs, or even free appliances or huge rebates on energy efficient appliances, so that these utility companies, again, the more efficient they become, the more they benefit from it, and the less energy that's being wasted, which means more pollution, basically. So basically every one of our households spends thousands of dollars a year on utility bills. Again, if my average bill is $100 a month, that's still $1,200 a year. We've got friends that say they spend $1,500 a month or $1,000 a month on average. That's a lot of money every year. And again, just by having a more efficient home, which again is the bottom line, this is something every one of us can and should do to the best of our ability, to do what we can afford, or think about maybe getting a home improvement loan to do some of these things that ultimately will pay the cost. Again, just think about solar. If I got a $10,000 loan to get a solar system that reduced my bill or eliminated it, if I was paying $200 a month for the second mortgage or the home improvement loan, but then that saved me $200 a month in electric bills, again, I'm kind of breaking even, and then once I pay that loan off, I'm ahead. And even if I sell the house, typically having energy efficient improvements like solar increases the value of the house, makes it more sellable. So all of these improvements that we could do, even if we had to get a loan to do them, again, a lot of these things can pay for themselves in really short amount of times. We just have to be thinking about a 2 to 5 year investment in our money that ultimately is going to make us much, much more efficient. But even cheaper things we can do, turning lights off when we're not using them, setting the thermostat lower in the summer, lower in the winter, and have it higher in the summer. Using a programmable thermostat that automatically turns the thermostat way down if nobody's home in the winter time, or turns it up much higher if you're gone in the summertime. And then it can automatically adjust the temperature about an hour before you get home so that it's comfortable again. Using compact fluorescents, closing the damper in the fireplace when you're not using it. Again, just little things that people forget to do, and you lose a lot of energy out your chimney. Another really big one that even I didn't know about for quite a while. Anything, your computer, your TV, your video games, anything that's electric that even if you're not using it, is using electricity. So having my entertainment center, for example, my television, the DVR, the Blu-ray, the stereo, are all plugged into a power bar. And if we're going to be gone on vacation or gone for the weekend, or even when we go to bed, just when you turn the TV off, hit the button on the power bar that shuts off all of the electricity to all your appliances. And then again, is it really that hard to remember to push the button in the morning before you turn the TV on? Or the same with your computer. Again, where I'm sitting right now, I've got 2 printers, my computer, the modem, my telephone, the router for my wireless are all plugged into a power bar. When we don't use the computer, that's off. And then again, otherwise you can just shut it down at night. The phone might need to be plugged in, but I don't really care. I shut it off at night. I don't need a phone call after 8 o'clock at night anyway. But again, it's not a ton of electricity, but it still makes a difference. It still is electricity that's being used, even if the appliance or even if your television isn't on. So just little habits like that. You've got appliances in your kitchen, like your coffee maker, electric can opener, a mixer. Leave them unplugged if you're not using them. All those little things add up. So those are things we can all do, including caulking and weather stripping our home, making sure our doors and windows are properly caulked. In California, you have no choice really but to have a water-saving faucet and shower head, so that's kind of a given. But just get in the habit of taking shorter showers. Be efficient. Get in there, get clean. Don't stand and just kind of waste water. And even, things like using a microwave to warm up food is really still more efficient than burning gas or electric, warming stuff up on the stove. Keeping the coils on the refrigerator clean, pulling the refrigerator away from the wall and vacuuming it really good behind there just makes it run more efficiently. If your fridge is a little bit older, look at all the weather stripping around it. It's one of my projects this summer is the weather stripping on our fridge is kind of shot near the bottom, so I know it's leaking cold out of there. The fridge is pretty old. I balance between just replacing it or repairing it, but the weather stripping's cheap. The fridge still works, so I'm just going to fix the weather stripping for now. Again, a lot of things like that we can do ourselves that don't cost any or don't cost much money. So the case study, last thing in this chapter, talks about green architecture. The Hearst Tower in Manhattan, 26% higher efficiency than a standard office building, and earned the first gold LEED certification from the U.S. Green Building Council. Basically, the interior design utilizes way more natural light, so it doesn't depend as much on internal lighting. 2,000 tons less steel were used in the manufacturing, and 90% of that steel that was used was recycled. Very efficient heating and cooling systems. This kind of icefall cooling system that basically is used not only for cooling the building, but for irrigating the plants that are in the building. And that water comes from rainwater that's collected. Again, just a lot of good technology that's out there that could be utilized even more in our homes. And again, I guess my thought always was the time to really pay for that stuff is when you have to remodel. You buy a house and get a mortgage, buy a new house. It's incorporated into the cost of the mortgage, so it's a little less painless. But the more we do it, the more we demand it, the more it's going to happen. So again, appreciate you being attentive during this semester. Obviously the final quiz will be coming up here shortly, but I really intend this course to not just be a course you try and get a passing grade in, but like other courses, but I would think more of this course than a lot of them everything we talk about, to some degree, each one of you can do something. You can write lawmakers and demand they change things. You can look at your own house and find ways that you can do more recycling, or that you can make your house more energy efficient, ways that you as an individual can consume less energy, things you can do around your workplace to help influence other people, things you can do at school to help influence other people. Just so much of this, everything ultimately that we talk about, it all has to start with each of us helping influence other people, and then ultimately, being involved in groups that can have big influences on policy, and then those policies driving changes that ultimately help us be a better society, better from the standpoint of utilizing the best technology that's less polluting, so that we can get away from those non-renewable resources and become much more dependent on the renewable resources that basically can provide us with all of the quality of life that we need forever. Fossil fuels can't do that. They're not going to last forever. They're going to run out. It's just a matter of how soon. So the more we can do to be proactive and keep these resources from running out before we've switched away from them, the less pollution we're going to cause, and ultimately the healthier planet we're going to have. And the healthier our planet is, the happier we're going to be. We got to get away from this notion of having quantity and be thinking more about quality. Again, whether that's stuff, I don't need to have the newest iPhone. I don't need to have a bigger TV. I'm perfectly happy with what I got. And that means that, again, I do all the other things right. I can have a healthier, happier earth to live in. And again, that's hopefully what all of us wants. So that's kind of my goal for this course, that you take some things away from it. Knowledge, you understand things better, but then also you can do things. You can make things happen because you understand more about what the problems are. So thanks again, and have a great break.